Hello everyone, this is Dan, and we're beginning our inverse function series, and today we are going to be looking at linear functions. Now, we usually do that because they're the easiest one to do, and we can kind of see how to do them for all of the rest. So, linear functions are normally in the form of y equals mx plus b. In order to get the inverse of this, and really the inverse of any function, all you have to do is you swap the x and the y's, and then you solve for y. So let's take a look at some examples together. We want to find the inverse function for f of x equals 2x plus 5. So first thing we're going to do is say y equals 2x plus 5. Now we swap our x and y's. So we say x equals 2y plus 5. Now we just solve for our y. So we're going to subtract 5 from both sides, get 2y equals x minus 5, and then we divide by the coefficient. So we get y equals x over 2 minus 5 over 2. This is close to being done, but not quite, because we haven't put it in function notation yet. So you'd say the inverse of f of x is x over 2 minus 5 over 2. And now this is done. Let's try another one. So find the inverse for g of x equals 4/5 x minus 20. So again, first thing, put in y equals, so 4/5 x minus 20. We swap our x's and our y's. So if x equals 4/5 y minus 20, and now we solve for our y. So we add 20 to both sides, and we get 4/5 y equals x plus 20, and then we divide by the coefficient. But you have to remember, when you divide by a fraction, it's the same as multiplying by its reciprocal. So we'd have y equals, and now we're going to have x times 5 over 4. So we have 5/4 x plus, now we have our 5 over 4 times 20. So say y equals 5 over 4x plus, now 20 times 5/4. An easy way to do this is 20 divided by 4, which is 5, times 5, which is 25. Now we're close to being done, but not quite. We still haven't put it in function notation. So we can say the inverse of g of x is 5/4 x plus 25. And that is our answer. Now, there's something that we haven't talked about yet, and that is our domain and range. Whenever you do an inverse, the domain and range for your original function swaps for your inverse. So your domain for your original becomes the range for your inverse. So if we have our f of x, and we have our inverse f of x, and we have our domain and our range, the domain becomes the range, and the range becomes the domain. Now, the cool thing about linear functions is that your domain and range is all real numbers for both of them. So when you swap them, they remain all real numbers. So whether you have a linear function or you're doing an inverse linear function, your domain and range is always going to be all real numbers. Makes it pretty easy. So let's try one more. We want to graph the inverse function of h of x equals 4/7 x minus 15, and then provide the domain and range. So let's go through our steps first. So we have y equals 4/7 x minus 15. We're going to swap our x and y's. So we have x equals 4/7 x minus 15. Oops, that's going to be y. Let's erase that. So 4/7 y minus 15. And then we're going to solve for our y. So we're going to add 15 to both sides. And we get 4/7 y equals x plus 15. And then we need to divide by the coefficient. But remember, when you divide by a fraction, you multiply by its reciprocal. So we have y equals 7/4 x plus 7/4 times 15. So if we do that multiplication out, what we get is 7 times 15 is 105/4. And again, we're close to being there, but not quite. So our inverse of h of x is 7/4 x plus 105/4. Now they want to know the domain and the range. But remember, for our h of x, it's all real numbers for both of them. So what does that mean for our inverse of h of x? Well, remember we said that they get swapped. So the domain becomes the range and the range becomes the domain. But for both of these, they're already all real numbers. So they just stay all real numbers for both. So now we want to graph these and see how it comes out. So first thing we are going to graph is our regular function. So our regular function was 4/7 x minus 15. So minus 15 is right there. And now we have 4/7 x. So we're going to rise 4 and we're going to go over 7. So that will put us there. And then for the reverse, we're going to go down 4 and go over 7. Should put us right there. So now we just want to use a straight edge and kind of graph this as best as we can. And now we want to try to graph our inverse function. So our inverse function was 7/4 x plus 105/4. So actually, let's write these down. So this is 4/7 x minus 15. And this is 7/4 x plus 105/4. So 105/4 is about 26.1 or 0.25. So we'll put that right there. And now we have to go up 7, which would be just above where our graph is, and then over 4. So we'd be somewhere over there. And then on the bottom, we go down 7 and then over 4. Just to be safe, we can go down another 7 and go over 4. And we should be somewhere around there. So let us graph this and see how this comes out. And the last thing we want to do is we want to graph y equals x. And the reason we're doing this is because whenever you do an inverse function, they will always be reflected across your y equals x line. So we just want to show you exactly what that means. So if you take a look at these two graphs, you can see that there's like a mirror that goes right along that y equals x line. And these two are just reflected about that. So this is how you do your inverse functions, especially for linear functions. I'll catch you next time when we start to go over quadratics. I hope you guys learned something. If you have any questions, don't hesitate to ask us. And I hope you had a good time. Bye.